And now in this lecture we'll answer two questions. In the first question we find out the area of this green shape, and in the second question we find out the length of this 97PQ that equals to x. We have to find out the value of x. So we start with the first question. In the drawing we have a circle inside this big semicircle. You know that this is 97AQ. This equals to 4 units in step. This is angle PQ8, this is the right angle. This is 970B, this equals to 1 unit in step. This is angle STB, that is the right angle. Again, our task is to find out the area of this green shape. So first of all, we define the radius of this semicircle as x and the radius of this small circle as y. In addition, we define the center of this small circle as O, and we define the center of this big semicircle. This point is point C. We define the point of tendency of tangent AB with this small circle. This point is point N. We define the point of tendency of tangent ST with this small circle. This point is point L. We define the point of tendency of tangent PQ with this small circle. This point is point H. And finally, we define the touching point of the big semicircle with this small circle. This point is point K. In the next step, we join points O and N together by a straight line. Point O is the center of the circle, point N is the point of the circle itself, therefore ON is the radius of this circle that equals to y according to our definition. The radius ON that equals to y, the radius ON is drawn to point N. That is the point of tendency of tangent AB with this small circle. And whenever you have a radius that is drawn to the point of tendency, then tangent AB will be perpendicular to the radius NO. If AB is perpendicular to NO, it means that this angle equals to 90 degrees, and this angle also equals to 90 degrees according to rule 1. AB is the diameter of the semicircle, and therefore it is absolutely a straight line. So if you focus on the upper side of the straight line AB, it's point Q. Here the sum of the angles must be equal to 180 degrees according to rule 3. Rule 3 states that the sum of the angles on one side of a straight line is equal to 180 degrees. So which angles we have at the upper side of the straight line AB at point Q? We have this angle, that is the right angle, plus this missing angle. In total, the sum of those two angles must be equal to 180 degrees according to rule 3. Therefore, this missing angle must be equal to 90 degrees in its size. Likewise, this is angle STB, that is the right angle. So, if we focus on the upper side of the straight line AB at point T, here the sum of the angles must be equal to 180 degrees according to rule 3. So which angles we have at the upper side of the straight line AB at point T? We have this angle that is right angle, plus this missing angle. In total, the sum of those two angles must be equal to 180 degrees according to rule 3. Therefore, this missing angle must be equal to 90 degrees in its size. In the next step, we join points O and S, O and L together by straight line. OL is of course the radius of the small circle. This is equals to y. The radius OL is drawn to point L, that is the point of tendency of tangent ST with this small circle. And whenever your radius is drawn to the point of tendency, then tangent ST will be perpendicular to the radius LO. If ST is perpendicular to LO, it means that this angle equals to 90 degrees, and this angle also equals to 90 degrees according to rule 1. So, in quadrangle OSTN, we have 1, 2, 3 right angles. The sum of 3 right angles is 270 degrees. So 270 degrees plus the size of this fourth missing angle, in total they must be equal to 360 degrees, according to the rule that the sum of the angles in any quadrangle is equal to 360 degrees. And therefore this fourth missing angle must be equal to 90 degrees in its size. So inside quadrangle OSTN we have 4 right angles, and according to rule 5, any quadrangle that has 4 right angles must be at least a rectangle, if not a square. So we relate to quadrangle OSTN as a rectangle because it has 4 right angles. But we also know that the opposite sides of a rectangle are equal to each other. So in rectangle OSTN, side OS must be equal to the opposite side TN. But OS is y, therefore the opposite side TN must be also equal to y units in its length. We repeat on the same process on this side of the drawing. That is to say, we join points O and H together by straight line. OH is of course the radius of this small circle, that is equals to y. The radius OH, that is equals to y, the radius OH is drawn to point H, that is the point of tendency of tangent PQ with this small circle. And whenever your radius is drawn to the point of tendency, then tangent PQ will be perpendicular to the radius HO. If PQ is perpendicular to HO, it means that this angle equals to 90 degrees. And this angle also equals to 90 degrees according to the same rule, rule 1. So inside quadrangle edge O N Q we have 1, 2, 3 right angles. The sum of 3 right angles is 270 degrees, so 270 degrees plus the size of this fourth missing angle, in total they must be equal to 360 degrees according to the rule that the sum of the angles in any quadrangle is equal to 360 degrees. And therefore this fourth missing angle must be equal to 90 degrees in its size. So inside quadrangle HONQ we have 4 right angles, and according to rule 5, any quadrangle that has 4 right angles must be this rectangle, if not a square. So we relate to quadrangle HONQ as a rectangle because it has 4 right angles. But we also know that the opposite sides of a rectangle are equal to each other. So in rectangle HONQ, side HO must be equal to the opposite side NQ. But HO is y, therefore the opposite side NQ must be also equal to y units in its length. QN equals to y. So in total, line 7, first of all, line 7 QT is a straight line because it is part of the straight line AB. Part of the straight line must be also a straight line. So QT must be a straight line. So QT in total equals to QN plus NT. That is to say qt equals to qn, that is y, plus nt, that is y. So in total, qt equals to 2y units in its length. AB is the diameter of the semicircle, and therefore it is equals to 2x. It is twice as long as the radius, it is x. So AB equals to, the diameter AB equals to 2x from one side, but from the other side, AB in total equals to AQ plus QT plus TB. Again, AB in total equals to AQ plus QT plus TB. So I already know. AB equals to AQ plus QT plus TB. So AB in total equals to AB is equals to 2x is equals to AQ is 4 plus QT is 2y plus TB equals to 1 unit in its length according to what is given as the question. So in total, if we found out that 2x equals to 4 plus 2y plus 1. So 2x equals to 2y, 4 plus 1 is 5. So in total 2x equals to 2y plus 5. Here we subtract 2y from this equation, and we get that 2x minus 2y equals to 5. Here we take 2 out of this, on those two expressions, and get that inside the brackets we will have x minus y. 2 was taken out as a common factor from those two expressions, so inside the brackets we have x minus y. So it is, this expression in total equals to 2 times x minus y equals to 5. Here we will divide this equation by 2 and get that x minus y equals to 5 over 2, this is 2.5. X minus y equals to 2.5. What is the length of this 9 segment CN? From the drawing it is very easy to see that CN in total equals to CB minus NT minus TB. Again, CN in total equals to CB minus NT minus TB. So I write it down. CN equals to CB minus NT minus TB. So again, if you found out that Cn in total equals to Cb minus Nt minus Tb. So Cn equals to Cb. Cb is the radius of the semicircle, that equals to x. Minus Nt. Nt equals to y. This is the radius of the small circle. Minus Tb. Tb equals to 1. So in total we found out that Cn equals to x minus y minus 1. X minus y is 2.5. So instead of x minus y by 2.5, and you get that Cn equals to x minus y is 2.5 minus 1. 2.5 minus 1 is 1.5. So in total we found out that Cn equals to 1.5 units in its length. This is 9 segments Cn. This is equals to 1.5 units in its length. In the next step, I will repeat on rule 9. We already talked about it, about rule 9 in the previous lectures. So repeat on rule 9 and we implement rule 9 in our drawing. According to rule 9, if two circles touch each other internally, then the straight line that connects their centers together passes through their touching point. Again, if two circles touch each other internally, then the straight line that connects their centers together passes through their touching point. So in the drawing, we have two circles. The center of this big circle is 0.0. The center of this small circle is 0.m. The straight line that connects their centers, together is of course the straight line OM. And according to this rule 9, the straight line OM must pass through their touching point, that is point P. And again, according to this rule 9, the straight line OM must pass through point P, that is their touching point. Or OMP is one straight line. Again, according to rule 9, OMP is one straight line. So we can actually implement rule 9 in our drawing. Why? Because in our drawing, we have an internal notch between the small circle and the big semicircle. And this point K. That is to say they touch each other internally at point K. Therefore we can implement here rule 9. The center of this big semicircle is at point C. The center of this small circle is at point O. The straight line that connects their centers together is of course the straight line CO. The straight line CO, according to rule 9, must pass through their touching point, that is point K. Again, the straight line CO must pass point K, that is their touching point. Or COK is one straight line. Again, COK is one straight line according to rule 9. So we join point C and O together by straight line. So from the drawing you can see that indeed the straight line CO passes through point K, that is their touching point, exactly according to rule 9. So according to rule 9, COK is one straight line. If COK is one straight line, it means that CO equals to CK minus OK. Again, CO equals to CK minus OK because of the fact that COK is one straight line. Again, CO equals to CK minus OK. So CO in total equals to CK. CK is the radius of the semicircle, this equals to X, minus OK. OK is the radius of this small circle, this equals to Y. So in total we found out that CO equals to X minus Y. CO equals to X minus Y, so write it down. But we already found out that X minus Y equals to 2.5. Therefore, the length of line segment CO is 2.5. In the next step, we copy the right angle CON in a new page and we implement the Pythagoras theorem on this right angle, triangle CON. According to the Pythagoras theorem, in any right angle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. Here by PT is the abbreviation for Pythagoras theorem. So actually, this is the right angle CON that is coming from the original drawing. And this right angle CON, according to the Pythagoras theorem, all C squared, that is the square of the hypotenuse, equals to ON squared plus NC squared. So I write it down. All C squared, that is the square of the hypotenuse, equals to ON squared plus CN squared. All C is 2.5, therefore all C squared is 2.5 squared, that is 6.25, and it equals to ON squared. ON is y, therefore ON squared is y squared, plus Cn squared. Cn is 1.5, therefore Cn squared is 1.5 squared, that is 2.25. So in total, if you found out that 6.25 equals to y squared plus 2.25. Here we subtract 2.25 from this equation, and we get that 6.25 minus 2.25 is 4, so 4 equals to y squared. Here we take a root out of this equation, and finally get that y equals to the square root of 4, that is 2. So if you found out that the radius of the small circle y equals to 2 units in its length, we already found out that x minus y equals to 2.5. We just right now found out that y is 2, so x minus y is x minus 2 equals to 2.5. Here we will add 2 to this equation and finally get that x equals to 2 plus 2.5 is 4.5. 4.5 is 9 over 2. So if you found out that the radius x of the big semicircle equals to either 9 over 2 units in itself, or in terms of numbers, the radius x of the big semicircle equals to 4.5 units in its length. Our task is to find out the area of this green shape. So what is the area of the green shape? From the drawing, it is very easy to see that the area of the green shape in total equals to the area of the big semicircle minus the area of the small circle. So I did now, the area of the green shape in total equals to the area of the big semicircle minus the area of the small circle. The radius of the semicircle equals to x, therefore the area of the semicircle must be equal to pi x squared over 2. Minus the area of the small circle. The radius of the small circle is y, therefore the area of the small circle must be equal to pi y squared. So we have here pi over 2 times x squared. X is 9 over 2, therefore x squared is 9 over 2 squared minus pi y squared. Nine over 2 squared is 9 squared, that is 81, over 2 squared, that is 4. So in total, this expression equals to pi over 2 times 81 over 4 minus pi y squared. Y is 2, therefore y squared is 2 squared, it is 4. So in total, this expression equals to 4 pi. So she found out that the area of the green shape equals to, here we have 81 pi in the numerator over 2.4, 2 times 4. 2 times 4 is 8. So in total she found out that the area of the semicircle equals to 81 pi over 8 square units in its size minus 4 pi, that is the area of the small circle. So here we multiply minus 4 pi by 8 and then we divide it by 8 in order to become comfortable with this expression, and we get that minus 4 pi times 8 is minus 32 pi. So 81 pi minus 32 pi is 49 pi over 8. 49 pi over 8 is 19.24 square units. And that is the answer to the question. And again, we should found out that the area that we're looking for in this question, that is the area of this green shape, it is equals to either 49 pi over 8 square units in its size, or in terms of numbers, the area of this green shape equals to 19.24 units in its size. So we finish with the first question. In the next step, I will present you the second question, and we will solve the second question of this lecture. Our task in the second question is to find out the length of this line segment PQ is equals to x. We have to find out the value of x. So in the drawing, we have a semicircle. Point O is the center of this semicircle. This is line segment OS. This is equals to 2 units in its length. This is line segment SV. This is equals to 1 unit in its length. This is angle PQS, that is the right angle. This is angle PTS, that is also a right angle. We also know that PT equals to TS. Okay, so if we define the length of PT as A, then the length of TS must be also equal to A because they are equal to each other. Again, our task is to find out the length of this line segment PQ is equals to x. We have to find out the value of x. So in the first step, we complete the semicircle to a circle. So we completed the semicircle to a circle, and we will extend line segment TS by straight line until it touches the circle. and we define the touching point of the extended line TS with this circle. This point is point M. In the next step, we join points P and M together by a straight line. By doing all those constructions, you can deduce peripheral angle PTM. According to what is given in the question, peripheral angle PTM is equal to 90 degrees in its size. It is a right angle, and peripheral angle PTM subtend on chord PM. Again, peripheral angle PTM, that is a right angle, subtend on chord PM. So actually, can implement here rule 5. So I please quickly on rule 5. We already talked about rule 5 in the previous lectures. According to rule 5, any peripheral angle is equal to 90 degrees in its size must subtend on the diameter of the circle. So in the drawing we have a circle. This is peripheral angle MAN, that is equal to 90 degrees in its size, and therefore according to this rule 5, peripheral angle MAN must subtend on the diameter of the circle. And indeed, peripheral angle MAN subtend on MN, that is the diameter of this circle. So according to rule 5, any peripheral angle that is equal to 90 degrees in its size must subtend on the diameter of the circle. Can actually implement rule 5 in our drawing. Why? Because in our drawing, we have peripheral angle PTM that is equal to 90 degrees in its size, and therefore according to rule 5, peripheral angle PTM must subtend on the diameter of the circle. Peripheral angle PTM subtend on PM, therefore according to rule 5, PM must be the diameter of the circle. So write it down. We actually found out that PM is the diameter of the circle according to rule 5. It is given the question that point O is the center of the circle. Point O is the center of the circle, point P is the point on the circle itself, therefore OP is the radius of the circle. Likewise, OB is also the radius of the circle, but OB equals to OS plus SB. So OB total equals to OS, that is 2, plus SB, that is 1. So in total, OB equals to 2 plus 1, that is 3. So she found out that the radius of this circle equals to 3 units in its length. So the radius of P equals to 3, and the radius of M also equals to 3 units in its length. Yeah, the radius of M equals to 3 units in its length. So in the next step, we'll do a construction. That is to say, from point S, we will do perpendicular on the diameter PM. Again, from point S, we will do perpendicular on the diameter PM. So actually, this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point S and the diameter PM. This point is point N. So by doing this construction, we're going to do the right triangle SNO. Those two angles, they are defined as vertex angles, and we know the vertex angles are equal to each other. So if we define the size of this angle as alpha, then the size of this angle must be also equal to alpha, because they are equal to each other. So in the lower right triangle SNO, this angle equals to alpha. This angle equals to 90 degrees, and therefore this first missing angle must be equal to 90 degrees minus alpha. Why? Because 90 degrees minus alpha plus alpha is 90 degrees, and 90 degrees plus 90 degrees it is equal to 180 degrees. That is the sum of the angles in any triangle. Likewise, in the upper right angle PQO, this angle equals to alpha. This angle equals to 90 degrees, and therefore this first missing angle must be equal to 90 degrees minus alpha, according to the sum rule that says that the sum of the angles in any triangle is equal to 180 degrees. It is very easy to see that the upper right triangle PQO is similar to the right lower triangle, triangle SNO, according to angle similarity rule. That is to say, those two angles are both equal to alpha, therefore they are equal to each other. Those two angles are both equal to 90 degrees minus alpha, therefore they are equal to each other. And finally, those two angles are both equal to 90 degrees, therefore they are equal to each other. So I should prove that all the figures of the upper right triangle PQO are correspondingly equal to all the figures of the right lower triangle, triangle SNO. Therefore, those two right triangles are similar to each other according to angle similarity rules. So it is known, if we found out that the right upper triangle, triangle PQO, is similar. This is the sign of similar to the right lower triangle, triangle ONS, according to angle similarity rule. And from the fact that those two right triangles are similar to each other, we will derive that the following relationship exists between their sides. We will derive that side SN of the right lower triangle ONS over side PQ of the upper right triangle PQO equals to side OS of the lower right triangle ONS over side PO of the upper right triangle PQO. Because again, from the fact that those two right triangles are similar to each other, we will derive that the following relationship exists between their sides. We will derive that side SN of the lower right triangle ONS over side PQ of the upper right triangle PQO is equals to side OS of the lower right triangle ONS over side PO of the upper right triangle PQO. NS is the missing side, so we leave it as it is, or SN, over PQ. PQ is the line segment that we are looking for in this question, and it is equals to x. We have to find out the value of x. And it is equals to OS. OS equals to 2 units in its length, according to what is given as the question, over PO. PO is the radius of this circle, that equals to 4 units in its length. So in total, if you found out that Sn over x equals to 2/3. Here we will multiply this equation by x, and we will get that the missing side Sn equals to 2/3 times x. Again, the missing side Sn equals to 2/3 x units in its length. So actually, This is the missing side Sn. Is equals to 2/3 x units in its length. In the next step, we define this angle as beta, and we'll focus on the small right triangle NSM. This is the small right green triangle, triangle NSM. In this small green right triangle SNM, this angle equals to beta. This angle equals to 90 degrees, and therefore this furthest angle must be equal to 90 degrees minus beta. Why? Because 90 degrees minus beta plus beta is 90 degrees, and 90 degrees plus 90 degrees, it is equals to 180 degrees. That is the sum of the angles in any triangle. Likewise, we focus on the big right triangle PTM. On the big right triangle PTM, this is angle beta, and therefore angle beta is the common angle that belongs to both triangles. Angle beta belongs to the green triangle NSM, and angle beta belongs to the big right triangle PTM. So this, in the right triangle PTM, this is angle beta, this angle equals to 90 degrees, and therefore this furthest angle must be equal to 90 degrees minus beta. According to the sum rule, that the sum of the angles in any triangle is equal to 180 degrees. It is very easy to see that the big right triangle PTM is similar to this small green right triangle and the same according to angle similarity rule. That is to say, those two angles are both equal to 90 degrees minus beta, therefore they are equal to each other. In addition, those two angles are both equal to 90 degrees and therefore they are equal to each other. And finally, this is angle beta, that is a common angle that belongs to both triangles. So we can find out that angle beta equals to itself is a common angle that belongs to both triangles. So I can prove that all the triangles of this big right triangle PTM are corresponding equal to all the triangles of this small right green triangle NSM. And therefore those two right triangles are similar to each other according to angle similarity rule. So I write it down, and we found out that the big right triangle PTM is similar to this small green right triangle NSM, according to angle similarity rule. And then we found out that the big right triangle PTM is similar, this is the same similar to the small right green triangle NSM according to angle similarity rule. And from the fact that those two right triangles are similar to each other, we derive that the following relationship exists between their sides. We derive that side Sn of the green right triangle NSM over side PT of the big right triangle PTM equals to side SM of the green right triangle NSM over side PM of the big right triangle PTM. And again, from the fact that those two right triangles are similar to each other, we derive that the following relationship exists between their sides. We derive that side SN of the green right triangle MSN over side PT of the big right triangle PTM equals to side SM of the green right triangle NSM over side PM of the big right triangle PTM. Sn we already found out that Sn equals to 2/3 x, 2/3 x over pt. According to our definition, pt equals to a units in its length and it is equals to Sm. Sm is the missing side, so we leave it as it is. Over Pm. Pm is the diameter of the circle. The radius is 3, therefore the diameter is 6. So Pm equals to 6. So in total, according to equation 1, we actually found out that 2/3 x over a equals to Sm over 6. Here we will post multiply this equation 1, and we get that according to equation 1, 2/3 x times 6 equals to a Sm. Here, in this side of equation 1, we have 6 over 3 is 2, and 2 times 2x is 4x. So in total, in this side of equation 1, we have 4x equals to ASM. And again, according to equation 1, we should find out that x equals to ASM. In the next step, I present to you the rule that we already talked about it in the previous lessons. This is actually rule 15, and we will implement rule 15 in our drawing. According to rule 15, if chord AB intersects with chord CD at point O, then the following equation is true, that AO times OB equals to CO times OD. So in the drawing we have a circle. This is chord AB that intersects with chord CD at point O. So in this drawing the following equation is true. AO times OB equals to CO times OD. Again, AO times OB equals to CO times OD. So we can actually implement rule 15 in our drawing. In our drawing, we have chord TM that intersects with chord TB at point S. Again, chord TM intersects with chord AB at point S. So all the requirements of rule 15 are satisfied, and therefore we can implement rule 15 in our drawing. So write it down. We found out that in our drawing, chord TM intersects with chord AB at point S. The intersection point occurs at point S. And therefore, according to rule 15, the following equation will be true, that TS times SM equals to AS times SB. Repeat again. According to rule 15, the following equation will be true. The TS times SM equals to AS times SB. TS equals to A according to our definition times SM. SM is the missing side, so we leave it as it is. And it is equals to AS. AS in total equals to AO plus OS. So AS equals to AO. AO is the radius of the circle, that is 3, plus OS. OS is 2. So in total AS equals to 3 plus 2, that is 5. Times SB. SB equals to 1. So in total, according to rule 15, I should found out that A times Sm equals to 5 times 1. 5 times 1 is 5. So in total, according to rule 15, I should found out that A times Sm equals to 5. This is according to equation 2. Because again, according to equation 2, we found out that A times Sm equals to 5. Well, according to equation 1, we already found out that A times Sm equals to 4x. So we have two different equations for the expression A times Sm. Therefore, we get equation 3 that says that A times Sm according to equation 1 must be equal to A times Sm according to equation 2. So it is on. According to equation 3, A times Sm according to equation 1 must be equal to A times Sm according to equation 2. A times Sm according to equation 1 is 4x, and it must be equal to A times Sm according to equation 2. A times Sm according to equation 2 is 5. So in total, according to equation 3, we found out that 4x equals to 5. Here we divide this equation 3 by 4, and finally we get that according to equation 3, x equals to 5 quarters. 5 quarters is 1.25. So if you found out that the length of this line segment PQ that is equals to x is equals to either 5 quarters units in its length, or in terms of numbers it is equals to 1.25 units in its length. And again, if we found out that the length of this line segment PQ is equals to x, it is equals to either 5 quarters units in its length, or in terms of numbers, PQ is equals to x is equal to 1.25 units in its length. So we finish with the second question. In the next step, we'll summarize the lecture. We start with the first question, of course. Our task in the first question was to find out the area of this green shape. So in the drawing we have a circle inside this big semicircle. This gives us the question that AQ equals to 4 units in its length, TB equals to 1 unit in its length. This is angle STB, this is the right angle. This is angle PQA, this is also a right angle. Again, our task is to find out the area of this green shape. So first of all, we define the center of this, we define the radius of this big semicircle as x, and the radius of this small circle as y. In addition, we define the center of this small circle, this point is point O, and we define the center of this big semicircle, this point is point C. In addition, we define the point of tendency of tangent AB with this small circle, this point is point N. Likewise, we defined the point of tendency of tangent ST with this small circle. This point is point L. And we also define the point of tendency of tangent PQ with this small circle. This point is point H. And finally, we define the touching point of this small circle with this big semicircle. This point is point K. In the next step, we join points O and N together by a straight line. Point O is the center of the circle. Point O is the center of the small circle. Point N is the point of the small circle itself. Therefore, ON is the radius of the small circle. That is equals to y according to our definition. The radius ON that equals to y. The radius ON is drawn to point N. That is the point of tendency of tangent AB with this small circle. And whenever you have a radius that is drawn to the point of tendency, then tangent AB will be perpendicular to the radius NO. If AB is perpendicular to NO, it means that this angle equals to 90 degrees and this angle also equals to 90 degrees according to rule 1. Angle PQA is the right angle according to what is given in the question. AB is the diameter of the semicircle and therefore it is absolutely a straight line. So if you focus on the upper side of the straight line AB at point Q, here the sum of the angles must be equal to 180 degrees according to rule 3. Rule 3 says that the sum of the angles on one side of a straight line is equal to 180 degrees. So which angles we have at the upper side of the straight line AB at point Q? We have this angle that is the right angle, plus this missing angle, in total the sum of those two angles must be equal to 180 degrees according to rule 3. Therefore this missing angle must be equal to 90 degrees in its size. Likewise, if we focus on the upper side of the straight line AB at point T, here the sum of the angles must be equal to 180 degrees according to rule 3. So each angle we have on the upper side of AB at point T, we have this angle STB, it is the right angle, plus this missing angle. In total the sum of those two angles must be equal to 180 degrees according to rule 3. Therefore this missing angle must be equal to 90 degrees in its size. In the next step, we join points O and S together by a straight line. OS is the radius of this small circle that is equals to y. The radius OS is drawn to point S, that is the point of tendency of tangent ST in this small circle. And whenever you have a radius that is drawn to the point of tendency, then tangent OS, tangent ST must be, tangent ST will be perpendicular to the radius LO. If ST is perpendicular to LO, it means that this angle equals to 90 degrees, and this angle also equals to 90 degrees according to rule 1. So in quadrilateral OSTN, we have 1, 2, 3 right angles. The sum of 3 right angles is 270 degrees. So 270 degrees plus the size of this 4 pieces again, in total it must be equal to 360 degrees according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. And therefore this 4 pieces again must be equal to 90 degrees in its size. So in size quadrilateral OLTN, we have 4 right angles, and according to rule 5, any quadrilateral that has 4 right angles must be this right angle in front of the square. So we relate to quadrilateral OLTN as right angle because it has 4 right angles. But we also know that the opposite sides of a right angle are equal to each other. So left angle OSTN, side OS must be equal to the opposite side TN. But OS is y, therefore the opposite side TN must be also equal to y units in its length. We repeat it on the same process on this side of the drawing. That is to say, we join points O and H together by a straight line. OH is the radius of the this small circle that is equals to y. The radius of OH that is equals to y. The radius of OH is drawn to point H, that is the point of tendency of tangent PQ with this small circle. Whenever your radius is drawn to the point of tendency, then tangent PQ will be perpendicular to the radius HO. If PQ is perpendicular to HO, it means that this angle equals to 90 degrees and this angle also equals to 90 degrees according to the same rule 1. So in quadrilateral HO and Q, we have 1, 2, 3 right angles. The sum of 3 right angles is 270 degrees, so 270 degrees plus the size of this 4 pieces again, in total must be equal to 360 degrees according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. And therefore this 4 pieces again must be equal to 90 degrees in its size. So inside quadrilateral HO and Q, we have 4 right angles, and according to rule 5, any quadrilateral that has 4 right angles must be this right angle in front of the square. So we have to consider edge O and Q as a rectangle because it has 4 right angles. But we know that the opposite sides of a rectangle are equal to each other. So rectangle edge O and Q, side edge O must be equal to the opposite side QN. But edge O is y, therefore the opposite side QN must be also equal to y units in its length. This is line segment QT. Line segment QT is part of the third line AB. Part of a third line must be also a third line. So QT is a third line. Therefore QT in total must be equal to QN plus MT. That is to say, QT equals to QN, that is y, plus MT, that is y. So in total QT equals to 2y. AB is the diameter of the semicircle. The radius is x, therefore the diameter must be equal to 2x. So from one side, AB equals to 2x. It is the diameter of the semicircle that equals to 2x, but from the other side, AB in total equals to AB in total equals to AQ plus QT plus TB. And again, on the other side, AB in total equals to AQ plus QT plus TB. AQ is 4, TQ is 2y, and TB is 1. So in total, 2x equals to 4 plus 2y plus 1. So 2x equals to 2y, 4 plus 1 is 5. So in total, 2x equals to 2y plus 5. Here we subtracted 2y from this equation. If I found out that 2x minus 2y equals to 5. Here we took 2 second factor from those two expressions. So inside the brackets, we have x minus y. So in total, if we found out that 2 times x minus y equals to 5, here we divided this equation by 2, and we found out that x minus y equals to 5 over 2, that is 2.5. So if we found out that x minus y equals to 2.5. What is the length of this line segment CN? From the drawing, it is very easy to see that CN in total equals to CB minus NT minus 3B. Again, CN in total equals to CB minus NT minus 3B. Okay, again, CN in total equals to CB minus NT minus 3B. So CN equals to CB. CB is the radius of the semicircle, that is x, minus NT, that is y, minus 3B, that is 1. So in total, if we found out that CN equals to CB, that is x, minus NT, that is y, minus 3B, that is 1. So in total, CN equals to x minus y, minus 1. X minus y is 2.5. So we substitute x minus y by 2.5. So it is CN equals to x minus y, that is 2.5 minus 1. 2.5 minus 1 is 1.5. So in total, we should find out that CN equals to 1.5 units in its length. This is line segment CN, that equals to 1.5 units in its length. So in the next step, I presented to you all 9, and we presented all 9 in our drawing. One picture on all 9. According to all 9, if two circles touch each other internally, then the third line that connects the circles together passes through their touching point. In the drawing, we have two circles. The center of this big circle is 0.0. The center of this small circle is 0.m. The third line that connects the circles together is, of course, the third line OM. And according to this all 9, the third line OM must pass through their touching point, that is point P. Again, the third line OM must pass through point P, that is their touching point. Or OMP is one third line. Again, OMP is one third line according to all 9. So we can implement all 9 in our drawing. Right, because in our drawing, we have an internal arch between the small circle and the big semicircle at this point, point K. And whenever you have an internal arch between two circles or semicircles, you can implement all 9. The center of this big semicircle is 0.C. The center of this small circle is 0.0. The third line that connects the centers together is, of course, the third line CO. And according to all 9, the third line CO must pass through their touching point, that is actually point K. Again, the third line CO must pass through point K, that is their touching point. Now COK is one third line. Again, according to all 9, COK is one third line. If COK is one third line, it means that CO must be equal to CK minus OK. Again, CO must be equal to CK minus OK. So CO equals to CK. CK is the radius of the semicircle, that is x, plus OK. OK is the radius of the small circle, that is y. So in total we should find out that CO equals to x minus y. The length of this line segment CO is x minus y. But we already found out that x minus y equals to 2.5. So CO is equals to x minus y equals to 2.5. We already found out that Cn equals to 1.5 and On is the radius of the small circle, that is y. So in the next step I copy the right triangle OCN in the page and implement it to Pythagoras theorem with this right triangle OCN. According to the Pythagoras theorem, in any right triangle the square of the hypotenuse equals to the sum of the squares of the perpendiculars. So actually this is the right triangle CON that is going from the original drawing. In this right triangle CON, OC squared, that is the square of the hypotenuse, equals to ON squared plus NC squared. OC is 2.5, therefore OC squared is 2.5 squared, that is 6.25, and it is equals to ON squared. ON is y, therefore ON squared is y squared, plus Cn squared. Cn is 1.5, therefore Cn squared is 1.5 squared, that is 2.25. So in total, we actually found out that 6.25 equals to y squared plus 2.25. Here we subtract 2.25 from this equation, and we found out that 6.25 minus 6.25 minus 2.25 equals to 4. So 4 equals to y squared. Here we took out of this equation and we found out that y equals to the square root of 4, that is 2. So we found out that the radius of the small circle y equals to 2 units in its length. We already found out that x minus y equals to 2.5. Y is 2, so x minus y is x minus 2. It equals to 2.5. Here we added 2 to this equation and we found out that x equals to 2 plus 2.5 is 4.5. 4.5 is 9 over 2. So we found out that the radius x of the big semicircle equals to either 9 over 2 units in its length, or in terms of numbers, x equals to 4.5 units in its length. Our test is to find out the area of this green shape. So what is the area of the green shape? From the drawing it is very easy to see that the area of the green shape in total equals to the area of the big semicircle minus the area of the small circle. Okay, again, the area of the green shape in total equals to the area of the big semicircle minus the area of the small circle. What is the area of the big semicircle? The radius of the big semicircle equals to x. Therefore, the area of the big semicircle must be equal to pi x squared over 2. Minus the area of the small circle. The radius of the small circle is y, therefore the area of the small circle must be equal to pi y squared. So in total, the area of the green shape must be equal to pi x squared over 2 minus pi y squared. X is 9 over 2, therefore x squared is 9 over 2 squared. So in total, this expression equals to pi over 2 times 9 over 2 squared minus pi times y squared. We open the brackets here. 9 over 2 squared equals to 9 squared, that is 81, over 2 squared, that is 4. So in total, this expression equals to 81 pi over 2 times 4 minus pi y squared. Y is 2, so y squared is 2 squared, that is 4. So in total, this expression equals to 4 pi. So it is minus 4 pi. So here we have 81 pi over 2 times 4, that is 8. So this expression in total equals to 81 pi over 8 minus 4 pi. Here we multiply minus 4 pi by 8 and then we divide it by 8 in order to account factor of this expression. So minus 4 pi times 8 is minus 42 pi divided by 8. 81 pi minus 42 pi is 94 pi divided by 8. So she found out that the area of this green shape equals to either 81 pi over 8 square units in size, or in terms of numbers, the area of this green shape equals to 19.24 square units in its size. So we finish with the first question. In the next step, I presented you the second question, and we answered on the second question of this lecture. In the second question, our task is to find out the length of this line segment PQ is equals to x. We have to find out the value of x. So in the drawing we have a semicircle. Point O is the center of this semicircle. According to what is given in the question, PT equals to TS. We also know that OS equals to 2 units in its length, SB equals to 1 unit in its length. This is angle PQS, that is the right angle. This is angle PQS, This is again PTS. This is also a right angle. Again, our test is to find out the length of this right angle PQ is equals to x. We know that PT equals to TS, according to what is given in the question. So if we define the length of PT as A, then TS must be also equal to A because they are equal to each other. So in the next step, we completed the semicircle to a circle, and we extended 970s by straight line until it touches the circle. We define the touching point of the extended 970s with this circle. This point is point M. We also join points P and M together by straight line. By doing all those constructions, we can deduce peripheral PTM. Peripheral PTM equals to 90 degrees in size, and its subset on chord PM. And according to rule 5, any peripheral is equal to 90 degrees in size, like this peripheral, must subset on the diameter of the circle. Peripheral PTM subset on PM, therefore PM must be the diameter of the circle according to rule 5. PM is the diameter of the circle according to rule 5. In the next step, we did the construction. That is to say, from point S, we do perpendicular on the diameter PM. Again, from point S, we do perpendicular on the diameter PM. So this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point S and the diameter PM. This point is point N. When doing this construction, you can deduce the right lower triangle, triangle OSN. Those two angles are defined as vertex angles, and we know that vertex angles are equal to each other. So if we define this angle as alpha, the size of this angle is alpha, then the size of this angle must be also equal to alpha because they are equal to each other. So in the right lower triangle OSN, this right triangle, this angle equals to alpha, this angle equals to 90 degrees, and therefore this vertex angle must be equal to 90 degrees minus alpha. Why? Because 90 degrees minus alpha plus alpha is 90 degrees, and 90 degrees plus 90 degrees is equals to 180 degrees. That is the sum of the angles in a triangle. Likewise, in the upper right triangle PQO, this angle equals to alpha, this angle equals to 90 degrees, and therefore this first missing angle must be equal to 90 degrees minus alpha according to the sum rule that the sum of the angles in a triangle is equal to 180 degrees. In the next step, we prove that the upper right triangle PQO is similar to the lower right triangle OSN according to angle similarity rule. That is to say, those two angles are both equal to alpha, therefore they are equal to each other. Those two angles are both equal to 90 degrees, and therefore they are equal to each other. And finally, those two angles are both equal to 90 degrees minus alpha, therefore they are equal to each other. So we can prove that all the figures of this upper right triangle PQO are correspondingly equal to all the figures of this right triangle ONS. And therefore those two right triangles are similar to each other according to angle similarity rule. So if we again, we should find out that the right upper triangle PQO is similar to the right lower triangle ONS according to angle similarity rule. And from the fact that those two right triangles are similar to each other, we will derive that the following relationship exists between their sides. We will derive that side SN of the right lower triangle OSN over side PQ of the right upper triangle PQO is equal to side OS of the right lower triangle OSN over side PO of the upper right triangle PQO. If we again, from the fact that those two right triangles are similar to each other, we derive that the following relationship exists between their sides. We derive that side SN of the right lower triangle ONS or side PQ of the upper right triangle PQO is equal to side OS of the right lower triangle ONS over side PO of the upper right triangle PQO. NS is the missing side, so we leave it as it is. PQ is the line segment that we are looking for in this question, and it is equal to X. And it is equal to OS. OS is 2 over PO. PO is the radius of the circle, that is 3. So in total, we should find out that Sn over X equals to 2/3. Here we multiply this equation by X, and we found out that the missing side Sn equals to 2/3 X. This is the missing side Sn. This is equals to 2/3 X. 2/3 X. In the next step, we define the size of this angle is beta, and focus on the right small green triangle S and M. In the green small triangle S and M, this angle equals to beta, this angle equals to 90 degrees, and therefore this vertex angle must be equal to 90 degrees minus beta. Y equals 90 degrees minus beta plus beta is 90 degrees, and 90 degrees plus 90 degrees, it is equals to 180 degrees. That is the sum of the angles in the triangle. Likewise, in the big right triangle PTM, this angle equals to beta, therefore angle beta is the common angle that belongs to both triangles. So this angle equals to beta, this angle equals to 90 degrees, and therefore this vertex angle must be equal to 90 degrees minus beta according to the symbol that the sum of the angles in any triangle is equal to 180 degrees. In the next step, we prove that the big right triangle PTM is similar to the small green right triangle NSM according to angle similarity rule. So why those two right triangles are similar to each other? First of all, this is angle beta, that is a common angle that belongs to both triangles, so we can write down that angle beta equals to itself is a common angle that belongs to both triangles. In addition, those two angles are both equal to 90 degrees and therefore they are equal to each other, and finally those two angles are both equal to 90 degrees minus beta, therefore they are equal to each other. So we should prove that all the figures of this big right triangle PTM are correspondingly equal to all the figures of this green small triangle NSM, and therefore those two right triangles are similar to each other according to angle similarity rule. And again, if we prove that the big right triangle PTM is similar, this is the sign of similar, to the right green small triangle NSM according to angle similarity rule. And from the fact that those two right triangles are similar to each other, we will derive that the following relationship exists between their sides. We will derive that side Sn of the green right triangle NSM over side PT of the big right triangle PTM is equal to side Sm of the green right triangle SNM over side PM of the big right triangle PTM. Repeat again, from the fact that those two right triangles are similar to each other, we derive that the following relationship exists between their sides. We derive that side Sn of the green right triangle NSM over side PT of the big right triangle PTM is equal to side SM of the green right triangle NSM over side PM of the big right triangle PTM. Sn equals to 2/3 x over PT. PT equals to A, according to our definition, and it is equals to SM. SM is the missing side, so we leave it as it is, over PM. PM is the diameter of the circle, the radius is 3, therefore the diameter is 6, so PM equals to 6. So in total, we found out that 2/3 x over A equals to SM over 6. Here we cross multiply this equation, and we found out that 2/3 x times 6 equals to ASM. 6 over 3 is 2, and 2 times 2x is 4x. So in total, in this side of the equation 1, we have 4x, so 4x equals to ASM. And again, according to equation 1, we found out that 4x equals to ASM. So in the drawing, we can implement rule 15. So, on rule 15, implement rule 15 in our drawing. According to rule 15, if chord AB intercepts with chord CD at point O, then AO times OB equals to CO times OD. So in the drawing we have a circle, and this is chord AB that intercepts with chord CD at point O. So in this drawing, the following equation will be true, that AO times OB equals to CO times OD. Again, AO times OB equals to CO times OD. So we can actually implement rule 15, this rule 15 in our drawing. Well, because in our drawing, we have chord TM that intercepts with chord AB at point S. Again, chord TM intercepts with chord AB at point S. So all the requirements of rule 15 are satisfied, and therefore we can implement here rule 15. And again, now when you are drawing, we have chord TM that intercepts with chord AB at point S. Point S is the intersection point of chord TM with chord AB. So we can implement here rule 15. According to rule 15, the following equation will be true, that TS times SM equals to AS times SB. Again, TS times SM equals to AS times SB. But again, according to rule 15, the following equation will be true, that TS times SM equals to AS times SB. TS is A, times SM. SM is the missing side, so we read as it is. Repeat again. TS is A and SM is the missing side. And it is equal to AS. AS in total equals to AO plus OS. So AS in total equals to AO. AO is the radius of the circle that is 3 plus OS. OS is 2. So in total AS equals to 3 plus 2, that is 5. Again, AS equals to 5 times SB. SB equals to 1. So in total, if you found out that A times SM equals to 5 times 1. 5 times 1 is 5. So in total, according to equation 2, if you found out that A times SM equals to 5. This is according to equation 2. While according to equation 1, we have already found out that A times SM equals to 4x. So we have two different equations for the expression A times SM. Therefore, we created equation 3 that states that A times SM according to equation 1 must be equal to A times SM according to equation 2. Repeat again, according to equation 3 that we created, equation 3 says that A times SM according to equation 1 must be equal to A times SM according to equation 2. A times SM according to equation 1 equals to 4x, and it must be equal to A times SM according to equation 2. A times SM according to equation 2 equals to 5. So in total, according to equation 3, we found out that 4x equals to 5. Here we divided this equation 3 by 4, and we found out that x equals to 5 quarters units in its length. On terms of numbers, 5 quarters is 1.25. So if you found out that the length of this line segment PQ is equal to x, is equal to either 5 quarters units in its length. On terms of numbers, PQ is equal to x is equal to 1.25 units in its length. Okay, thank you very much.